Graphing a system of inequalities is very similar to graphing a single inequality, except we should wait until we have all of the information to shade. Because only the things that you can see, it says only the points that satisfy the entire system should be shaded. So that means they would have to satisfy, in this case, both of these equations. This should be y, I believe. That was a typo on this question. Y is less than negative 3x plus 21. That's already in slope-intercept form, so I could actually figure out how to graph that one pretty easily. 21 is going to be way up here-ish. And a slope of negative 3 means that it's going to go down 3 into the right 1. So ultimately it would come down, I'll call this 7, 0. I know it'll have to go down 7 times because 21 divided by 3 is 7. It'll have to go down 7 times, which means it's going to go over 7 times to the right. So that's how I knew it was going to be 7, 0. Alternatively, I could have used the same technique I did on my previous examples to find the x and the y intercept. But this is the point 0, 21. That's the point 7, 0. We know the line goes through those 2 points. And I know the line is going to be a dashed line. So let me give some notes here. Point 0, 21, the point 7, 0, those are the intercepts. The strict inequality means dashed line. So when I draw this in here, it should be a dashed line. And I'll test to see which side of the line is correct. This doesn't go through the origin, so I'll go ahead and use the origin as a test point. If a line did go through the origin, I just have to pick a different point. But in this case, it doesn't, so I'll go ahead and use the origin as a test point. We get 0 is less than 0 plus 21. Again, just plugging in zeros for both y and x. Both of those end up just going away or becoming zeros. And so 0 is less than 21 is true, which means that that is the correct side of the line. But I don't want to shade quite yet, because I need whatever is shaded, I need it to satisfy both inequalities. Right now, I just know that the stuff that's over here satisfies the first inequality. I need to also consider the second one, so that's what I'm going to do now. The second inequality says x is less than 2y. Alright, this goes through the origin. I'm noticing that because if I plug in 0 for x, I get 0 for y. And so finding the intercepts isn't going to work here, because that'll just give me the same point again. Instead, well, let me think of this as 2y equals x. You know, just putting an equal sign in there instead of a less than, that way, or a greater than, so I don't have to worry about it. Divide both sides by 2, I get y equals 1/2 x. You can see I have a slope of 1/2. So that means if I was to go up 1, I'd have to go over 2. I'm not too terribly concerned with that being accurate, although I think that's probably close enough. So we know that we would also consider the point, or this would also go through the point 2, 1. That's up 1 and to the right 2. So let's see, this will be a dashed line, because this is a strict inequality. It says less than. This will be dashed. So I'll draw a dashed line in here. And I just need to figure out which way to shade. I can't test the origin, because the origin is on the line. I need to test a point that's in one of the two, on one of the two sides. And so I'm just going to bump myself up to test the point 0, 1, because that's not on the line. I know the origin is on the line. If I go directly up, I'm not going to remain on the line. So I'll test the point 0, 1. With the original inequality here, this gives me 0 is less than 2, which is true. Which means the point that I tested right here, this is 0, 1, satisfies the points on this line. So that means I would want to shade above that line. So I need to make both of these things happy. That's my line 1, this is my line 2. I want to shade below and to the left of line 1, but above and to the left of line 2. So if you kind of think about what's going on here, one way that I kind of like to do these sometimes is I like to think about what sections are not going to work out. So clearly the stuff that's over here and over here is not going to work out because it's on the wrong side of line 1. The stuff that's on the wrong side of line 2 is over here and over here. Well, I've already crossed that one off, but whatever. You can see this section over here is the only one that's on the correct side of both of those lines. So that is the section we would shade, and we want to make sure we don't cross over any of these lines. You don't want to shade multiple of these regions. So there's our first system of inequalities.